Alright, wave-particle duality. Yay. It's really just a conflict. It's either one or the other, wave or particle. Yeah, it's just fundamental, so it all goes back to this two-slit experiment. I'll play some of the worst video ever made on the subject, read a comment, try to explain why this controversy exists at all, and why, again, this is just one of those points in physics where they had a choice. Answer the question badly on soft evidence with phantasmagorical, fairy, silly explanations, or do a little more hard work and find the real physical explanation. Yeah, without inventing new dimensions or invisible functions and clearly they're just invisible men. These are people at a, this is like Columbo, and you're watching a guy trying to solve a crime, and he starts looking for the signs of the invisible man, because that's, makes his job easier. If he can just blame it on the invisible man, he doesn't have to do any work. Just say, oh, there's a sign the invisible man was here. There's an undrunk cup of coffee. Invisible men always leave one of those behind. Anyway, just, I mean, it's physics should be embarrassed. The religions have more coherent, honest arguments defending their nonsense than this crap. Anyway, in Mendicam, there are various interpretations of QM. You also say your interpretation of QM agrees with the math. I agree with the experiments, in the sense the experiments happen and they produce results, and those results have variables that go into the equations. The frequency of the light, the distance of the target, those things are all going to affect what kind of image you see on the wall. And yes, so I agree with all of that. What I don't agree with is, the Huygens nonsense and the silly explanations. I don't agree with the idea that they're presuming photons are interfering with themselves. Yes, no, I don't agree with that. I agree there's an angular component that is consistent. Okay. Here is a model that builds upon a slightly different math but produces the same results as Copenhagen. Copenhagen isn't an experiment. It isn't evidence. It's a silly interpretation. I don't care about interpretations. So here you're talking about math. Copenhagen really isn't math. Copenhagen is Huygens on steroids. It's just an invisible man who takes care of the mission of figuring out where the photon goes. Radar for photons. Without a lot of woo-woo. Okay, says you. Sorry, I didn't see this video yet. So maybe that'll be a separate video on the subject of that video that he posted here in this comment. Why I won't do that. Anyway. Is this interpretation closer compared to yours? No, it won't be, because my interpretation has nothing to do with any kind of photons interfering with themselves or anything that happens after the slit. The event happens at the slit. It doesn't happen later. In it, there are particles and waves that interact with the slits in the experiment. Again, there's no waves. So I might as well do this part here. I can just look. I can see where people decided, okay, let's do this wavy thought, because it's like a radio wave, right? We typically think of radio waves coming off of radio towers, in this, that's the old images from the movies, and whoa, look at that, it's waves. It's really not. It's just a bunch of little things, and they're all moving in straight lines. Okay, and it's just when they're produced. So they're produced at different times, and so they have a different, starting point, so to speak. They're at a different rate in their progress, but it's really just it's a mass of particles. Particle, particle, particle. A mass of particles, particle, a mass of particles, particle, a mass of particles, and they're all moving in straight lines. But that's all it is. It's just a masses. And the same thing with a light bulb. Now you can turn a light bulb on and you're not going to see the nanometer wavelength of the actual light, but you could turn the light bulb on and off, and yes, it's going to start appearing like it's a wave of light, because it's going to be, you know, coming out in clumps. And you're going to assume that those wave fronts are real waves, and they're not manufactured the same way as waves are manufactured at all. They're manufactured in a completely different way. They're not taking advantage of tension in a medium or anything. It's just a clump of photons, a clump of photons, a clump of photons, a clump of photons. And the actual wavelength of the light is actually the same thing, except it's just ton, 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 ton. That's the wavelength of the photon. So a lot of little dots, that's blue light. Dot, 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 dot. Dots further apart, that's red light. That's all. Now, you could talk like it's a wave, but we know we can make it out of dots. You don't need to have a medium. You don't need to have this swirly bitty. There's no way to manufacture it as a wave. It's non-intuitive in a lot of ways, but it's not. I mean, it's intuitive to jump to the conclusion of waves whenever you see this bulk coming at you. But the way it was manufactured has nothing to do with that. Doesn't have to have anything to do with that. And you can clearly understand that the wave is made out of a bunch of stuff, and a bunch of stuff, and a bunch of stuff at a frequency. All frequency does not mean wave. Bullets fired from a gun, for example. You just don't you can say, like when a machine gun shoots bullets, they call it a wave of bullets. But you know it's not a wave of bullets. You know it's individual bullets fired, and they're all going in straight lines. It's not complicated. Anyway, it has no fields, though. Well, whatever that is. You don't need fields. Again, it's just... Well, anyway. Since you've no math, well, I don't have no math. I'm just saying, I mean, I can give you math. I'll give you math right now. But I just don't see the point. I mean, the variables are the same. You're looking for an explanation for why it's happening, not some kind of new math. Oh, damn. Could you draw a schematics of the fields interacting in the double slit experiment? Again, it's not fields. Fields don't interact. Force interacts, and force is made of tons of light, of radio waves, of bits of crap moving, going the speed of light, without all the other explanations and stuff. Well, I don't even know what that means, but no, I can't do it without the other explanations, because that's called context. And yes, physics is a little bit complicated, and it can't, you know, people keep doing it in this cartoon manner, and it's inaccurate. So you have to spend at least enough time to get what you're conceptually saying correct. All right, so here's another criticism I found of the two-slit experiment. Is they're always talking about the Huygens idea and the single slit. And we know there's a certain limit to how wide I can make this slit. If I make this slit a little bit wider, Huygens doesn't happen, nothing happens. You get no interference pattern. The light just shoots through the middle and lands right there. So it just goes right through. No effect. So there's some kind of distance that matters here in terms of this wave of light, and how big a gap the wave of light can break off at the ends and do its Huygens magic. I'm interfering with myself. But ironically, right, so if I could put the single slit next to the double slit experiment, you'll realize the double slit is by necessity a wider total. Okay? And the catch is, how does the single photon breach the entire double slit experiment? How come it can't go wide enough to get through a wide single slit, yet it can get wide enough to go through the bigger opening of the double slit experiment? Right? That's a catch there. That's something to say, hey, wait a minute, this explanation's got some flaws. Because, you know, how come all of a sudden Huygens works in the double slit, which is wider, and it doesn't work in the single slit when it's wide, but not incredibly wide, but too wide to create a pattern? And even this, so my argument would be is this kind of obvious argument, which is when we know from electrodynamics, which the subject used to be quantum electrodynamics, but they ruined it and turned it into phantasmagorical Holy Ghost religious crap. But you know from electrodynamics that when two things are far apart from each other, there's no electrical potential between them, unless you put something in between them to create this narrower gap. So you know kind of the gaps are very important in electronics. The gap is, the more you bring a gap closer, the more likely it is you're going to get a spark between them. See, no likelihood of spark here, likelihood of spark here. So you kind of know that when you're moving things together, that you're changing the electrical potential in this atmosphere. The actual atmosphere between the two surfaces changes as you bring surfaces closer and closer together. And so that's sort of intuitive. I mean, that's sort of like, this adds up now. You say, well, what's the distinguishing feature here? Well, first we know it's the fact that slits have to get narrow. And Newton knew that. So 400 years ago, Newton tells you, he explicitly called, and they're named after him, Newton's rings. He shows you this phenomenon. And what do? You wait hundreds of years to do a two-slit experiment and blame it on this bullshit interference crap, because you know you can't explain Newton's rings with this interference crap. And then you fix that by saying, well, let's go back and dig up that Huygens crap, because that we can use that crap to make that go away. The fact that it's single slit diffraction, interference pattern, and really double slits are just a redundancy. That's like saying the 4-slit experiment proves it, or the 17-slit experiment proves it. No, the single slit experiment is the one that needs to be explained. And that's the one that's just so obvious. What's the distinguishing feature here? Ah, the width of the slit. The material is different. Not the photons, the material that it's interacting with. This is a phenomenon of an interaction with matter. This isn't a phenomenon of photons that don't know where they are, or electrons that don't know where they are. It's about electricity and electrodynamics. It's about electrons, damn it. Okay, so here's the explanation. Alright. This isn't the final version, but it's getting damn close. It's pretty much finished. It's finished as a you don't need to go much further than this. Alright, so when the slits are wide, but not too wide. Obviously when they're too wide, there's no electrical potential. The electrons just circle, so I'll do extra wide slits just so you don't get confused. So when the slits are extra wide, all the electrons just hang around the edges here. And they space themselves around the surface of all things. All material surfaces have free electrons around them. Because your protons are essentially, it's like a Pluto. Okay, you count, let's say that you counted the hard planets, the ones on the inside, as electrons that are bound. So they're part of your matter. But those gaseous big balls, they're like free electrons. They'll break loose with you just blow on them hard enough, and they'll blow out of orbit. They're weakly bound. And that's happening inside of atoms, because the proton's creating more attraction force, which is actually non-repulsion force. But anyway, it's creating more of that than what it's holding. It can hold more stuff, it just can't hold it tight. So it can only hold a certain number of electrons tight. They gotta be close. And the ones far away, yeah, it can hold them loose. Okay, so there's lots of loose electrons around every atom. Lots of them. And depending on where they're going, that's force. But anyway, I won't get into the force argument. Anyway, so the electrons are close to the material and spread out evenly. That's what electrons do. They spread out evenly. Electrons like to be at an even distance from each other. So if there's 5 of them, they will do this. They'll spread out they'll find a comfort zone where they are essentially balanced in their hatred for each other. It's just hate everywhere here. Hate, 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 hate. So they'll find a balance of hate, repulsion. Anyway, they'll spread the hate, so to speak. So now if I bring these surfaces closer together, what's happening is the electrons start going out here because they're getting the electrical potential thing is happening. And so the protons from this side are now attracting electrons too. So now the free electrons can make a choice. So they can, now they were really tightly compressed here and they didn't like it. And now their hate can spread out into here. And so now they're getting ready to do the electric spark thing. But there has to be an electric potential to run the spark. But the electrons already set it up. They're just waiting for the voltage. So if you give them enough voltage, it'll go right across the gap because the electrons are already lining up. So I shouldn't have squiggled that because I kind of ruined that drawing. So I'll just make the drawing over again. Alright, so we have these electrons and they're going to do this even spacing thing again. Now what happens is the photon can miss them. So that means the photon just ends up being that center part of the two-slit experiment, the bright one. All the stuff, because this is tiny, tiny, this is big, big. So this gap on the wall is just a little sliver. So all the light that misses goes right in here. And the stuff that hits, it has a choice. Now, I would argue the choice is kind of just left-right, but let's just say we're going to, just for the sake of simplifying the argument, when the photon hits the electron, three things can happen. The electron goes this way, the electron goes straight, or the electron goes that way. And it's true for each single electron. And this angle, theta, okay, for my math, is always the same. Alright, and it depends on the electron. So if it's a blue light, that angle gets smaller. If it's red light, that angle gets bigger. And so there's a choice. So you can just sort of get it right now. You can see it happening right before your eyes. That this will end up being always proportional. So no matter wherever I move the target, they're always going to be proportionally spaced where these can land, like as bars. And so there'll be places that will be dead spaces that are the dead spaces between the electrons, and the places that will have bars that'll be these angles. And so as you narrow the gap, then fewer electrons can fit. And eventually you get to the point where you'll only fit one electron. And when you do that, then you create much fewer dots, and it gets kind of interesting. So here's the single slit in that circumstance. Is this is like what you might think of as a diffraction grating. Okay, 1,000 lines or 500 lines. The same idea is happening. There's only room for one electron, and the one electron might even be forward. So it might even be in this location because it can't even fit between the gap anymore. And the other electrons will be on these angles. And so they'll be dividing the point of possible refraction. Now, the ability for the light to go this way is sort of dependent on this electron being able to it hits one electron, that electron hits another electron, that electron does the same thing to create the electron goes, it creates the angle hits this one can go straight or this way, so it can widen the gap, but it's very unlikely. So those are the very dim spots. But the main spots will be the forward one and the peripheries. The two peripheries would be these electrons. So anyway, the point is the math is just going to be the same exact math. You just replace sine theta with this theta, and you base that theta on the frequency of the light going in. So that angle is a certain angle, I don't know, 22 degrees, I could make one up, but it's something that's establishable as an angle. And you just do the experiment once, get the angle, and then you know it for all the rest of the experiments. Okay, so that's all it is. It's a standard angle that the electrons will always line up on, essentially. And then if I did the double slit experiment, all we're really then doing is changing the electrical potential. So when I make a second slit, what I've done is taken this electrical potential and I've changed it into two halves of that. And that's what's combining the two patterns, is the fact that you're changing these electrons would line up at a certain distance if it was a single slit, but because there's two slits, they'll merge that force between the two, and so the pattern will be changed because of that. And you'll also have these four extras, you know, the ones that line up off the edge of the surface, and those essentially ends up, so this part of the slit creates the center pattern, then this electrons are maybe creating the second pattern, something like that. I mean, I haven't gone through all the details of that one yet, but clearly a nice mechanical explanation that has to do with the fact that the slits are the things that are the real moving variable in the experiment. They're the thing you vary, and you vary the outcome. Clearly the matter is doing something. It's not what the photons are doing, it's what the matter is doing. And they keep wanting to make this into something photons do, when this is not something photons do. This is something matter does. Okay. Alright, now we'll play this. This is the standard model of physics. An absolute crock of shit video. 38 dislikes, 2,290 something maybe. Can't really read it. 2,291 likes. A disgusting ratio of 1,000 to 1. Well, 100 to 1. Yeah. Almost. You know, and it's just junk. Absolute junk science. Isn't true to the truth, the facts, the real circumstance, and this is the experiment. I mean, again, they're saying this is the experiment that just makes it impossible to see it any other way, and yet this is how uncareful they are in describing the experiment. So this is a critical experiment in the diagnostics, and this is the critical piece of blood evidence in a case. And yet they're this reckless about explaining how it was collected, you know, what refrigerators it was kept in, how it was preserved, how the experimenter did the test on the DNA. Totally forget all that crap. We don't have to have integrity to this evidence at all. We can just make it up, essentially. We'll make up a fake story talking about how great this evidence is, and it's the evidence that's going to convict. And it's just disgusting for science to do this, to let this be how they propagandize about one of the most serious pursuits the humans can endeavor in, this acquisition of truth. They have no respect for it whatsoever. It's just religious theology, and they're propagandizing for their frickin' God.
It's called the double slit experiment. And seriously, you're going to want to remember this one because...
seriously, you sound like you're 13 years old, and that really doesn't work for me. But anyway, I'm stuck with it. I mean, sounds cute and hot and all that shit, but 13, which is kind of pedophile-y, so that doesn't work for me either.
In my opinion, it's the most important experiment in quantum mechanics, and...
Okay, it's the most important experiment in quantum mechanics. Wake up, this is important, and I'm going to just lie. Well, not on purpose, it's just that I'm too fucking ignorant to tell you the truth, I guess. This is no excuse for how inaccurate this is.
We'll come back to it so many times.
Yes. Come back to the false premise of the false evidence. So yes, we have the false premise, which is it has to be a wave, it has to be a wave, it has to be a wave, it has to be a wave. And our proof is this fake evidence, this fake evidence, this fake evidence.
We'll talk about the experiment when it's done with small particles.
Again, so this idea of not even, you know, this lack of definition about these distinctions, about something being elemental, fundamental, or a particle in itself. Electrons aren't, strictly speaking, particles. They're schools, they're collections, they're amalgamations. Just like you know, again, people really wouldn't call atoms anymore a particle. Okay, it's not a particle anymore. You can call it a thing, an entity, but you don't call it a particle.
You need a gun that will shoot the particles here. Then put up a board that will detect where the particles land. In between, you set up another board, but one with 2 slits in it that the particles can get through.
And again, this done by Newton 400 years ago. Just get rid of this and you have the same experiment, and you're saying, why does it happen? So why don't you explain the single slit? Why don't you explain Newton's rings?
What happens when you shoot the particles? Most won't get through, but those that do will mostly end up in 2 big clusters behind the holes.
Right, so instead of saying particles, you should say something like, well, look, if we use something big and mechanical in our big universe that isn't going to be affected by, static electricity, yeah, the bullets go through the holes, and the only way they can go the wrong way is they have to, bust and break because they hit some kind of edge here. So if we discount the ones that hit the edge, all the ones we shoot will end up going straight in one straight line, and this is the only way they can get through, is go from the gun and go over to the other end, and they can't do it any other way. Now that'd be the honest way to describe it, right?
Situations with waves is...
But then the honest thing to say after that is, but we're not talking about bullets, we're not talking about the big universe, we're talking about the electric universe, we're talking about quantum electrodynamics, we're talking about the smallest little bits in the universe. And yes, the rules are a little bit different. Just a little bit.
Very different. We'll have the same setup now, except we'll create the waves at this end, and at the other end, we'll measure where the waves hit with the most intensity.
The waves. So let's just assume, okay, this is how you solve wave-particle duality, is by just grossly assuming. But anyway, okay, she's just giving the 2 sides of the story. Let's see what waves do.
First, we'll cover up one hole and see what happens. The wave goes through the hole and then starts...
Okay, now we know, okay, that that's true, all right? That this is what waves do. And that's worth explaining, that how come waves do this, but later on when you're going to talk about this quantum crap, well, this quantum crap doesn't do this. It interferes with itself in a single slit. How come these waves aren't going to do what the Huygens waves are going to do? How come these waves aren't going to behave anything like quantum waves?
Make these semicircular wavefronts. Therefore, the wave hits most intensely right behind the open slit. So you might expect that when both holes are open, that the pattern will look something like this. But it doesn't at all. When both slits are open, the wave splits up and then interferes with itself. When 2 peaks or 2 troughs meet, they make a bigger peak or trough. Where a trough and a peak meet, they cancel each other out. Imagine that these are water waves and you're in the water. If you're in these...
The graphics don't exactly they're not exactly in sync with the description. And they could have straightened that a little bit. That's a little crookedy. But anyway, yes. So again, this setup, as if, oh look, this is going to be just like what we're going to find later, on off. And again, these interference patterns are, this is where there's more wave, this is where it's quiet, this is where there's more wave. I mean, it's not exactly the same thing.
Waters, you're getting bobbed up and down a lot. On the other hand, these waters are pretty calm.
Yeah,
so
exactly.
Wall, you can
so that doesn't have anything to do with this experiment either.
Expect the waves to hit most intensely around these areas and least in these. So you'll get a pattern like this for intensity. Most things that
and again, the double slit isn't really look like this for intensity, so not really.
Familiar with seem to act like particles. So people...
I mean, it does this thing. It waves big and then it gets small, and then it waves big and then it gets small, and then it waves big and gets small. That's the double slit pattern.
Expected that even when we're dealing with things so small that we couldn't see them with our eyes, they'd be particle-like. Let's put that to the test using the double slit experiment on something extremely small, say an electron.
Again, their choice of using electrons, why? Why did they do this? When it's really visually more obvious when you use light. Who has electron guns? Nobody. How many times has this experiment been done with a laser beam? You get a huge, brilliant, clear pattern. I mean, why talk about electrons when the electron pattern actually is kind of dull.
We won't be able to see the electron as it goes through, but what we'll do is put a special screen in on this side that lights up whenever the electron hits it. We're going to use an electron gun that only fires one electron through at a time. Here goes. Well,
It says don't do it at home. You can't do it at home, actually. You know, unless you got a vacuum somewhere.
that looks like particles to me, because a wave would be spread out across the whole screen, not arriving in these localized dots. But
So this is the two slit. They're saying it's arriving in dots, but like I said, the voice isn't in sync with these images. So now she's gonna.
wait, look at the pattern forming on the screen. That's
Okay.
not what we'd expect of particles at all. In fact, I'll show you that this result seems impossible.
Okay, it seems impossible, but it really isn't. But I mean, this isn't what you would expect from particles. So again, it's more like saying, okay, if this was bowling balls, so we're just going to ignore that we're really talking about something happening between the smallest things in the universe. And we know the smallest things in the universe are controlled by strong and weak forces and all kinds of other forces that don't have anything to do with the big world.
First, let's see what happens when we cover up one slit.
I mean, again, the fact that you have to remind physicists that we're talking about, you know, nuclear stuff, the fact that we have to explain that, hey, wait a minute, physics has to do with the nuclear bits too, you know, remind them.
We get one big splodge of points behind the open slit.
Okay, now, so right there, this is just such a gross lie, right? We know this isn't true. This is not true. It's not even close to being true. Newton knew this wasn't true. There's no way to say this is what you expect. This is what happens. That's not what happens. It has nothing to do with what happens. It's just a frickin' pile of wrong. Okay, this is a wrong description of reality. It's wrong. It's not instructional. You're doing an instructional video and it's wrong.
Okay, but what we just found was that the electrons are like particles in that they're in one spot and not spread out.
Well, like I said, we know from Newton that we get Newton's rings here, which is the same thing as an on-off pattern. So again, wrong.
So each electron must go through just one slit. Well, we already know that electrons going through this one slit must make a pattern like this. And similarly...
Okay, so we already know that. So that's the false premise. We know there must be just a lump here. Instead, we already know, 400 years ago, we already know that if you do this with electrons or we do this with photons, Newton knew it with photons, even smaller than electrons, that you're going to get a pattern here. That's a 400-year-old fact, named after the most famous man in physics, Newton. Newton's rings. You can't cover that up. You can't pretend you don't know it exists. You can't do instructional videos denying its existence while you're insulting the guy who discovered it 400 years ago.
For electrons going through the other slit.
Well, 300.
So we should expect this, which is not what we're getting at all.
So again, this wouldn't be your expectation. It wouldn't be Newton's expectation. So can we say it that way? The guy you're insulting, we could say Newton certainly didn't expect that. So don't put that in his expectation mind, because even with his, he had 1% of the technology you have, 1%, and he knew that wasn't the truth. What's your excuse for not knowing that's not the truth?
The result seems to defy logic.
It defies honesty. That's what it defies. It defies accuracy and honesty. That's all it defies. Accuracy and honesty. That's it. It's religious propaganda. That's the definition of religious propaganda. It defies honesty and accuracy. That's the definition of religious propaganda. And that's what this is.
And that is a big problem for physicists. You see,
it's a big problem if they have stupid notions in their head and they begin to not care about the evidence. And all they care about is confirmation. Something, confirm what I believe, confirm my rubbish. I don't want to hear about anything that's obnoxious to what I need is confirmation. And frankly, the single slit experiment is obnoxious, because even I know that if I made this video doing the Huygens thing, you'd have a lot more down ratings, but there'd be a lot of people saying, what the hell is that crap? What do you mean? Photons have radar?
If the universe is inconsistent with itself, there would be no point in trying to make sense of it.
And again, inconsistent because you completely misdescribed the reality. There was no inconsistency. Single slit makes pattern, double slit makes more pattern. Gee, where's the inconsistency? No inconsistency whatsoever.
It wouldn't work, and physicists would be out of the job. Luckily for us, a few smart people came up with a cunning solution.
A cunning lie for the single slit, okay, called Huygens, and rubbish, complete religious rubbish, like Heisenberg. We'll just pretend photons don't know what they're doing. Woo! The invisible man is pushing them.
And if it's troubling, then please just remember, we were desperate.
Okay, now that's funny, huh? So that's what science has come down to. Well, we can't think of it, so we'll just invent some gods. Because we're lazy like the rest of the historical characters. We don't want to deal with this fact that we got to go look a little harder. We got to think a little harder. Well, we'll just make a god and let him fix it. Invisible man moves the little photons inside the slit and no problem.
You see, our previous reasoning implicitly assumed many things that we usually hold to be true.
Yes, and you just lied about them. So what's the point? You just got them all wrong. So you got all the axioms wrong, and now you're going to tell us what the truth is. Oh, charming.
But if we can let a couple of these go, then we can come up with a solution.
Yes, the wrong answer again.
Our first assumption was that because the electron looks like a particle when it's observed, that means it's a particle while we're not observing it.
So now they're getting into this nonsensical observation thing. Now none of it had anything to do with an observation, right? You shoot a gun, there's two slits, there's a pattern on the wall. None of it's observationally dicey. So this doesn't have anything to do with observing anything. Slits are not observing photons. Newsflash.
This is the kind of assumption that is really important in science. We like to think that our experiments are simply unveiling the reality that was already there, rather than changing it completely.
I don't even know what that means. That's just nonsensical. The experiment is merely providing you some access to what happens when you stick your finger in it. That's it. It's not complicated. It gives you some information about what it's going to do, what it's made of. Is it hard? Is it soft? Is it this? Is it that? Now, what kind of conclusions you jump to, that's your problem. That's not physics' fault. That's not the experiment's fault. That's your fault.
Quantum mechanics lets that comforting idea go. Instead, while we're not looking, quantum mechanics doesn't say anything about the actual electron itself.
Right, it just turns it into an invisible man, so now we don't have to worry about figuring out the physics. We can just say, screw the physics, screw explanations. Okay, we'll just make up a story. It started over here, and then it went to Goldilocks' house, and then it went to Red Riding Hood's house, and it got a little bit too fat, and then it got, it needed an antacid, so it went to the grocery store, and it got some Maalox, and then it had to go potty, and so it went to the gas station, and the bathroom was all dirty, so it didn't know what to do, and it got all confused, and so it had a stroke, and it died. Oh yeah, that photon didn't make it.
Instead, it talks about something called the electron's wave function.
Right, so just the probability wave function would be even more better. Probability wave.
The wave function is this wave that exists at all times, even when the existence of the electron itself becomes questionable.
Right, now that's just, where do you have evidence for this? The existence of the electron itself becomes questionable. How is that preserving anything called continuity or conservation? I think that's just breaking conservation all over the place.
It's a wave similar to a water wave. Therefore, in the double slit situation...
Again, we're talking about an on-off pattern. So again, this is the simplest pattern you could possibly make. On-off, on-off, on-off. No simpler pattern possible. So let's not exaggerate.
It interferes with itself. So, the intensity profile of the wave looks like this, just like with water waves.
Right, except when you do the single slit experiment, it doesn't look anything at all alike. So, single slit experiment with little particles of light and electrons doesn't look anything like water waves at all. Completely opposite evidence. So one piece of evidence says yes, the other piece of evidence says no. You slide the piece that says no under the Huygens rug, and you just play with this piece that confirms your bias. You don't, and it just ignore the truth. The truth.
Okay, great. We've got this wave, but what on earth has it got to do with our electron? This is where we need to let go of our second assumption.
Right, this is where you keep talking about this. Let go. There's no evolution. There's only God. Just ignore all the facts like I do and just God, God, God. It's all about the God of the wave and the Heisenberg, Huygens, dead cat philosophy.
Basically, ever since Newton, physicists have believed that there isn't random...
So let's just remember, Newton. This is the fucker who figured out Newton's rings. This is the guy who found the interference pattern first. And he was a responsible scientist and said, what the fuck? Yeah, I have no idea. I don't know what the fuck that is. And then some Huygens guy gave him some kind of silly thing and he said, well, okay, maybe. I'm not sure though. That sounds a little fucked up too. Yeah, Newton didn't know what it was.
Chance in how our universe acts. If you think back to our experiments with regular particles, we said that they didn't all land in the same spot. However, according to Newton's laws, this is just because they must be going in slightly different directions and speeds at the start.
So again, this is according to Newton's laws. There's nothing about Newton's laws that says anything about the Newton's rings. So again, let's pretend that Newton had a solution.
If you get them all exactly the same, they'd fall in exactly the same spot.
Right, now that law is rock solid and you have absolutely no evidence that it isn't the truth. That if they don't interact with anything, they move in a straight line. That's Newton's argument. Newton says you shoot this thing, it goes straight unless something alters it. It goes straight. It has an identity. It goes in a place through reality and it lands somewhere. And you don't have one piece of hard evidence to dispute that. Not a single shred.
Quantum mechanics, though, the opposite is true. Even if it were possible to get the electron gun to shoot in the exact same way each time.
See, this is their way of, they're trying to kill determinism. So this is the religious part of it. They don't like physics being this hard, nasty thing, that takes away all our specialness and turns us into fucking retarded, stinky robots. Because, oh no, we have to be special.
The electrons wouldn't all land in the same spot. There is an element of chance involved, and there is absolutely no way to predict where...
There is absolutely no way. So it's not like it's an inaccessible fact. There's no way. It can't be a fact. And we know that there is a fact. There is a fact that if you can actually be sure of where your photon's going when you shoot it, if you aim it, then all of this bullshit goes away. There's no doubts. It doesn't invisible. It doesn't do any of that stuff. And I'll guarantee you'll still get your pattern.
A particular electron is going to go. That's like saying, when I let an apple go, 2/3 of the time it'll fall down, and 1/3 of the time...
Yes, well, we're talking again. So just ignore that this thing started off as quantum electrodynamics. Electrons are the most electrical thing in the universe, right? So let's just pretend that we can talk about electrons like they're apples, when we know electrons hate flying straight. I mean, they just fucking hate it, because they're moving through fields that are changing in potential every single step they take. They're accessing a different... It's like something being super sensitive to gravity, and everything it passes has an influence on its movement because they're super sensitive to gravity. You can understand how nothing would ever fly straight, okay, if it was super sensitive, because that means every time it just moved a little bit towards something or a little bit away from something, it had to move even further towards it.
And it'll fall up. For no reason, and there's
No reason. Again, no reason. Where in the physics have you demonstrated any of this crap where you can have the arrogance to say there is no reason? Not that you are too stupid to find the reason. You're too lazy to find the reason. No, there is no reason. No, there is a reason. No reason to think there is not. No evidence supporting a theory that there isn't a reason.
no possible way to predict which way.
No possible way to predict. Again, it's not possible to do it.
The apple will fall next time you drop it. However, quantum mechanics doesn't say that where our electron will turn up is completely random, because then our...
Oh, yeah, well, it's not completely random. It's just partially random. Like, it's kind of like throwing dice, except the dice are thrown by the invisible man. So, yes, you can figure out how the dice will bounce, but the invisible man threw them, so you don't know where he threw them from. Ha-ha. Catch-22.
A pattern would look like this. On the other hand, what we get for the double slit experiment is this, and for the single...
So this is also not the truth, as we know. This pattern goes like this, and then it goes to nothing, and then it goes back up a little, and then it goes back up a little. So we know this pattern is much more complicated, and we know the single slit is not what she's going to show here, right? She hasn't even talked about the single slit experiment yet, but watch what she puts here. She's just going to put a pile of manure here, and we know that's not the truth. Newton knew that. That guy you just made a cartoon out of knew that.
Slit one, this.
Oh, there you go. Now, so what do you want me to say? This is being broadcast as if it's educational to a bunch of losers. Look at this first comment, for example. I can't believe I'm actually understanding quantum mechanics. Thank you so much. This is probably the best explanation ever. You just use simple diagrams. Some people just use fancy animations and mess up my mind. This was very helpful. So this is very helpful to learn a lie, a falsehood, a fake, a phony, garbage, propaganda, nonsense, crap. Crap science.
We can see the electrons seem more likely to turn up in some spots, but how do we figure out where? Re-enter the wave function. Remember the intensity profiles for the wave...
There's no wave function, trust me. Okay, there really isn't any wave function. Okay, if you want to get into functions, you get that with refraction and reflection off a glass. You might get some functions. There's no functions involved in this mathematics. Okay, this mathematics is pretty sterile. All it's doing is cutting everything into the wavelength of the light. That's how it's creating the separation between the slits, and the distance is just being dictated again by the wavelength of the light. So there's no function here. There's no probability function.
Function in each case is like this and this. As you can probably...
So Newton's rings don't exist. No. We don't know that exists at all. And there's a function for the non-existent Newton ring.
Guess now, the electrons are most likely to turn up where the intensity of the wave function...
I'm just saying this is glaringly wrong, right? I mean, everybody can agree who knows anything at all about physics, right? So apparently nobody in this audience knows anything about physics, because anybody who knows anything about physics knows this is glaringly inaccurate. Glaringly inaccurate.
Is big. If you want more details on how to exactly calculate this, then let me know in the comments.
Yes, please. You already got everybody idiot servanted. Why not make them double idiot servanti? I mean, yes, make people dumber and dumber. Yes, I've already made you dumber. I've already made you dumb. Let me make you dumber.
And I might make a video about it.
Yes, well, I'll be so goddamn happy that more propaganda on the internet. How thrilling. So I have to go find her math.
Let me recap. When we're not looking, the electron itself...
So again, this really wasn't about any of this not looking part. So let's just remember that. So now she's recapping, talking about this not looking thing has something to do with any of this shit. And that actually has nothing to do with what was in this video. That has to do with this stupid experiment that was never really done, where they detect which slit it went through, and then they don't look at the results. And when they don't look at the results, oh, it works. But when they look at the results, it doesn't work. And there's no not looking shit here.
May or may not exist, but in its place is some sort of wave. Quantum mechanics says that while you're not experimenting on it, the electron doesn't have a position. Even its wave function is spread out.
It's on-offness is spread out, whatever that means. It's the idea that it will, when it encounters certain circumstances, there will be a consistency to the possible outcomes. They'll be circular. So the deeper you go in, you'll start at 1 all over again. And then you go deeper in and you start at 1 all over again. You go deeper in, you go... That's all it is. It's Feynman made it kind of clear that all they're really talking about is just duplicating the same probability through the media, which means all you're really doing is going from the first atom to the second atom to the third atom to the fourth atom, and depending on where you hit the charged body, how deeply you hit it, you'll get a different response. The mirror will be at a different angle depending on how your angle hitting it. Wow, big surprise.
But when we attempt to measure the position of the electron, the universe realizes it needs to produce an electron, so it picks where the electron will turn up, semi-randomly.
Hey, it is the Invisible Man, and it is godlike. So there we go. So this is religion after all, right? I accused it of sounding kind of religious, and we have all this nice religious symbolology here now. So we really know that this isn't anything about fucking physics or science or a disciplined effort to understand the truth. It's just fucking religion.
Based on its wave function. Yeah, I know. Well, I'll leave you with that for now, and...
La 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 la.
Next week I'll try and expose you to more of this quantum mechanics thing, but I'm sorry, it really only gets weirder.
Yeah, you know, it only gets sillier and stupider and obviously more propagandist and more, let's not pay any attention to actual facts and let's not have any discipline whatsoever in evaluating the evidence. Let's just convict him because we think he's ugly. And we like her. This is just physics for the bigots and you know, the people who want to make the truth, not people who want to find the truth. Oh, horribly obnoxious. All right, so anyway, part of this was done because thankfully somebody has been playing with my forum and they have posted posts. So this was the second video on the subject of wave particle. So I'll play a little bit of this first video. It's just as bad. So now we have the little boy version. We did the little girl version. La 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 la. Okay, so we'll jump ahead to here.
Isaac Newton was one of the earliest. Newton believed that light is made up of tiny, atom-like particles which he called corpuscles. Using this assumption, he was able to explain some properties of light. For example, refraction, which is how a beam of light appears to bend as it passes from air into water. But, in science, even geniuses sometimes get things wrong.
Right, so these people know the truth. We know Newton was wrong. We know it, we know it, we know it, we know it, we know it. And we don't have evidence to back it up, though.
In the 19th century, long after Newton died, scientists did a series of experiments that clearly showed that light can't be made up of tiny atom-like particles. For one thing...
Yeah, a series of experiments.
Two beams of light that cross paths don't interact with each other at all.
Okay, now this, I just thought, so this is why I played this little clip, just because I wanted to get this in here. So he's making the argument like two laser beams don't interact. And, oh, how could it possibly be particles? Why wouldn't two waves interact? What is more likely? Me throwing a baseball, two guys throw baseballs at each other and the two baseballs don't hit each other. Or me making a wave on one end of the pool and somebody else making a wave on the other end of the pool and those two waves interacting. Which one's more likely? Let's see, the waves interacting happens 100% of the time. The two baseballs hitting each other, 1 in 100. Now, I'm not arguing that the baseballs are hitting. I'm just arguing this example wouldn't work for waves either. I mean, the fact that they can't even figure out that this is a problem for wave theorists also. Why aren't these waves interacting with each other? They're waves. Why aren't they banging into each other? It's the same argument for both theories. This is not evidence for either side. It's evidence against both sides. I mean, it's one of those things we have to say, oh shit, I guess we have to accept that the forces don't interact with forces. Has nothing to do with particle theory. as evidence. So this is, again, just more propaganda, for fuck's sake.
If light were made of tiny solid balls, then you would expect that some of the particles from beam
And if it was made of waves, I would expect that the waves would interfere with each other. Yes.
A would
God
crash into some of
damn.
the particles from beam B. If that happened, the two particles involved in the collision would bounce off in random directions.
And if they were waves, we'd expect the waves to deflect into each other, and we get all kinds of wavy patterns here. And we don't.
But that doesn't happen. The beams of light pass right through each other, as you can check for yourself with two laser pointers and some chalk dust. For another
And you could go out into a puddle and make two waves and watch the waves crash into each other and interfere with each other.
thing, light makes interference patterns. Interference patterns are the complicated undulations that happen when two wave...
Well, they're not really complicated because it's on, off, on, off. I mean, really, it's really not that complicated. I mean, it's one of the simplest pattern interactions possible.
patterns occupy the same space. They can be seen when two objects disturb the surface of a still pond. And also...
Yeah, so exactly the same scenario as the two laser beams, and you got interference. And how come you didn't get that with the light? Oh, that's because it's a silly analogy.
Only waves make interference patterns.
So let's see if he gets to anything. I can't remember how he screws up the two-slit experiment. Let's see, that's Einstein's... Well, that's shining light on a metal, I think. I don't know, it didn't look like Einstein. Yeah, so he doesn't do the two-slit in here, at least not in this part. But it's all this wavy crap. And it's just such a, you know, like, it's just such a silly...
Properties like interference either. So these quanta of light aren't at all like the tiny hard spheres Newton imagined. This results that light sometimes behaves like a particle, and sometimes behaves like a wave.
Yeah, like and seems and looks. I mean, these aren't really scientific terms, so why are you playing with them? I mean, the idea that it can be both is silly. So let's just understand it's either corpuscles, it's either a thing that is elemental and indestructible, or it's some thing traveling through a medium of some kind. You know, that's getting into the whole electric and magnetic crap, which is just crap because you can't find anything more unmagnetic than a photon. I mean, it's the most unmagnetic thing, I think, in the universe. It just couldn't give a shit. You can throw as much magnetism at it, you know, forever and ever and ever, and you'll never bend it just a tiny bit.
Led to a revolutionary new physics theory called quantum mechanics.
Right. That used to be quantum electrodynamics. You know, because it used to be about nuclear bits instead of invisible Heisenbergy. We're not looking at you. You can do stuff to trick us now. Looking! Oh, you tricked us. Yeah. Fuck. Fantasy bullshit religion. It's not physics. Alright, anyway. It's fantasy. Fantasy. Fantasia. Yeah. Fuck. Anyway. Dancing elephants and sugar plum fairies. So, till next time. Such. So forth and whatnot. Link to the message board below. And such.